Now let's look at the general case for distance in 2 dimensions. First of all, you will see this on your math chart. The distance equals the difference of the 2x coordinates squared plus the difference of the 2 y coordinates squared. Might be interesting to look at that question that's on the side. How could I relate this to slope? There's another way to word this if you can think of it. So proving the distance formula, where does that formula come from? So I'm going to take a picture here where I have a random coordinate on the lower left. Doesn't really matter, but I'm going to do it this way to make it easier. And that coordinate we're going to call x1, y1. And then the other coordinate is x2, y2. And I want to find the length of that segment. Now I did draw in a right triangle. That was to help. And this point right here is important. Now how did I know that that point was x2? Well, I'm sliding along the horizontal here, so the y is not changing. And so the y has to be the same. It has to be, oops, y1. Excuse me just a second. Hate it when that happens. So the y value is actually going to be y1 because it doesn't change. And the x value is going to be x2. And you can see if I go vertically here, the only thing that should change is the y value. So I can say that this distance here for the horizontal leg is x2 minus x1. There it is. And for the vertical leg, it should be y2 minus y1. So now what's the next step? Let's substitute these two values into the Pythagorean theorem. There's the Pythagorean theorem. We're going to have one leg squared plus the other leg squared equals the hypotenuse squared. Well, x2 minus x1, that's the leg, and I put parentheses around it and a square. y2 minus y1, that's the other leg. I put a parentheses around it and square. The reason I replaced d here is I'm trying to go for the distance formula, which uses d. Now, I'm trying to make it d equals, but I have d squared. So I'm going to undo it the same way I did before. I'm going to take the square root of both sides, which means this is the distance formula. So we've derived the distance formula using the Pythagorean theorem. So here's an example. First of all, always write down your formula. So there's my formula, and I'm going to put these points in. So here's x1, y1, and x2, y2. So 3 is going to go right here, 4 is going to go in y1, negative 2 is going to go over here, and negative 5 is going to go over there. Most people find it easier to focus first on x or y. So here's the substituted. So you can see there's the two x's, x2, and there's the x1. And here's the y2, and the only one left is the y1. So I've got distance equals negative 5 squared plus negative 9 squared, because negative 2 minus 3 is negative 5. And negative 5 minus 4 is negative 9. Squaring those, I get 25 plus 81, or square root of 106. Many times I'll be very happy with having your answer like that in the square root. I will teach you how to pull out some perfect squares. And if you really want a decimal and I say to what place value, you can just grab a calculator for that. So for further reflection on this page of notes, you do have your individual practice problem to do. How could we rewrite the distance formula using our prior knowledge of slope? I'll give you a hint. Rise should show up, maybe something else. Why is it really important to label when using the distance formula? Hopefully you saw that it's easy to mix numbers up, so you have to be very careful when using it. Honestly, a lot of times when I'm doing distance, I will do it graphically by just looking at the legs of the triangle instead of doing the whole distance formula. So you are allowed to use Pythagorean theorem. What do you think the distance formula might look like in 3 dimensions? So that's something to ponder. And the Pythagorean theorem and the distance formula are really the same or different formulas. You tell me which one, because why is that?